This is the lesson for the first part of Chapter 3, Section 2, so let's see what it's talking about. And it asks us to write the product as one power. And so what we've got here are three different rules we're going to be taking a look at, and so we're going to figure out what those rules are. So let's take a look at the first one. It says 2 to the third power. So 2 to the third power is just 3 2's being multiplied. And then we're taking that number and multiplying it by 2 to the fourth power. And so you can see how we have 4 2's here. And so what I'm going to do, since all the numbers are being multiplied, I could write it as 1 power. And so the way we're going to do that is take the base number, the number that's being multiplied to, and we're going to count up how many we have. So we got 3 2's, and 4 2's make 7 2's. So basically the way I got that is I took the 3 and added it to the 4, and that's how I'm getting 2 to the 7th power. And therein lies our rule. And so the rule is, when we're multiplying with the same base, we can add the exponents. And so that's what we're going to do with these next few problems. So 10 to the 5th would be 5 10's being multiplied together. 10 to the 7th would be 7 of those 10's being multiplied together. So I want to find out how many we have all together. I will add the exponents since we have the same base. And so that makes 10 to the 12th power. Look in the next one, it's the same thing with variables. You just take how many you have. So here we have 9 x's being multiplied together, and I'm going to tack on 8 more x's. And since they're all being multiplied together, we can just write it as 1 exponent. And so x to the 17th power. On the next one, we have 7 14's. So 14's the base. They're being multiplied. 14's being multiplied 7 times. Then we have 14 being multiplied 9 times. So we're going to count up how many of those 14's we have, and that makes a total of 16 of them. So 14 to the 16th power. Well, when we divide, we've got a little different rule. So let's take a look at how that rule would work. So we'll take a look at the first example to figure out what the rule is. So if I have 6 or 8 to the 6th power, or 6 8's being multiplied, I'm going to write out all those 6's or 8's here. And then I'm going to draw my fraction bar, and I'll write out the 2 8's being multiplied. And so when we've got division, we can go ahead and cancel out some 8's. So you see how here we have 8 or 6 8's being multiplied. So there's 6 different factors we have, and we have some of the same factors down below. Here we have 2 8's. Well, these two factors will cancel out to make 1, and so now they're gone. And then these 2 8's will cancel out to make 1 as well. And so they're gone. So what we have left are no more 8's on the bottom. So we have a number 1 on the bottom, and we have 1, 2, 3, 4 8's on top. So we have 8 to the 4th power. So 8 to the 4th over 1 is the same thing as just 8 to the 4th. So there must be a little rule we can make this problem go a little quicker rather than having to multiply or write out all these 8's. Kind of like what we did up here with the 2's. Well, the rule would be this. Since I'm taking away some 8's that are in common between the top and the bottom, I subtract the number of 8's I had from the bottom from the number that I had on top. So it would look like this. 8 to the 6 minus 2. So I go ahead and do that subtraction, and that leaves me with my answer, 8 to the 4th power. So let's take a look and use that rule with this one. So I have the base of 12, and I have 9 12's on top, 8 12's on the bottom. So I'm going to take away the number of 12's I have from the bottom from the ones from the top, and that leaves me with 1 12 on top, so just 12 to the 1st power. Well, here's a little different situation, because notice that we have more 12's on the bottom of the fraction than the top. So when I do the subtraction, I end up with a negative number, x to the negative 7th power. And so whenever I have negative exponents, that's the same thing as the reciprocal of positive exponents. So it's 1 over x to the 7th power, and that's the answer that we'd want. And it kind of makes sense if I went ahead to write this out, and I'll do that with the next problem because the numbers are a little smaller. You see, if I go ahead and do the rule, I have 9, and then I got to take away the bottom from the top, so it leaves me with that negative exponent again. 1 over 9 to the negative 6, which we said would be 1 over 9 to the positive 6. And that'll be the answer. But let's take a look at that problem, since there are not so many of them. And see how I have those 3 9's on top, and down below I have the 9 9's. exponents. So there's 4, 5, 6, 7, 8, and then 9. So I got those 9 nines on the bottom. So when I go ahead and cancel out the common 9, so like I'll cancel this one with this one with this one, and this one with this one. And let's see how many are left on the bottom. I've got 1, 2, 3, 4, 5, 6. And that's what my answer says as well. See, there's everything canceled out on top, so I'm left with 1. And I have those 6 nines being multiplied together on the bottom. So that's how I can get that answer as well. So that's how it ends up working. So on the next one, the variables, same sort of thing. It does it the same way. You always take away the bottom from the top. And so in this case, I'm left with more a's on top than the bottom, so that's why it's just a to the 5th. Well, now we've got a different rule, and it's a power raised to a power. And so if I wrote out what this represents 3 to the 2nd times 3 to the 2nd times 3 to the 2nd, and then one more time, 3 to the 2nd. See, 3 to the 2nd is being raised to the 4th power, so I've got 1, 2, 3, 4 of those 3 to the 2nds. Well, if I use the multiplication rule, which says if I have the same base, like I do here, these 3's, and then I would just add up those exponents. So 2 plus 2 plus 2 plus 2. And so that would make 3 to the 8th power, and that would be my answer. But there's got to be a faster way, and there is. Notice how when I went ahead and wrote those 3 to the 2nds out, there are 4 of them. And I am adding the same number 4 times. So that means I could multiply. I can multiply the 3 to the 2nd times by 4. So I can multiply the exponents, and that would give me the same answer. So again, the rule is when we have a power to a power, I can multiply the exponents because it's repeated addition. But when I'm adding, or when I'm multiplying bases with the same base, I have to add up those exponents. So let's try this next one using that rule. So 4 to the 6th times by negative 2. Now notice how it gives me a negative exponent. So I have to rewrite that with positive exponents. And that's just taking the reciprocal. All the negative exponents represent is that it's a fraction. It's a smaller number. And so if I took the reciprocal, I'd get that fraction. Same thing on this next one. Negative 1 times 5 gives me negative 5, so I have 3 to the negative 5th. But again, that's the same thing as 1 over 3 to the 5th power. And the next one is a little bit different because we have a 0 as an exponent. Negative 2 times 0 gives me 0. And when I go ahead and take a number, any number to the 0 power, we just end up with 1. So to simplify it, that's what it would be. 10 to the 3rd times with raised to the 4th power means I'm multiplying the 3 and 4 and I get 12. And 10 to the 12th would be the answer. So those are the types of problems you're going to see on tonight's homework. Good luck.